Hello and welcome back to a new video and a new session in our continued journey of trying to master geometry. And our today's agenda is practice and exercise, specifically working with triangles and the angle sum property of a triangle. So the angle sum property we have already looked at and derived also. If there is a triangle ABC, I know in any given triangle, angle A plus angle B plus angle C is equal to 180 degree. That is one idea that we will be using a lot. And the second is that if I create an exterior angle, take any side and stretch it out straight, the angle created is an exterior angle, and this angle is equal to the sum of the opposite two angles. That means this angle, let's say if this is x and I say what is the value of angle ABX, this angle is going to be angle A plus angle C. So these would be a couple of core ideas that we will be using, and we might extend the story a little bit to a quadrilateral also. So if I have a quadrilateral, the four angles of the quadrilateral are going to add up to 360 degrees. And remember, the proof also was very easy. Our quadrilateral is two triangles. One triangle has 180 degrees, the other triangle has 180 degrees. That means the same idea. So our quadrilateral has 360 degrees. So we will be using these very basic ideas, but this time in problem solving. So before you get started with the discussion, you can find the questions in the description box below. Please try out the questions by yourself, struggle with them a little if they are difficult, and then only join the discussion. Because if you try it out yourself once, the discussion will make more sense to you, and maybe if you are able to solve it yourself, that will be even more fun than simply listening to the solution, right? So please try out the questions and then join the discussion. So I hope you tried out the questions and had a little fun with them. This was our very first question, marked as example number 2. And this is the approximate representation of the figure given in the problem. And the story given to us is AD is equal to CD is equal to BC. AD is equal to CD is equal to BC. And the other piece of information given to me is angle BCE. Angle BCE is equal to 96 degrees. And your question is, what is angle DBC? So you are asked about this angle. So how would I go about solving this? I will use another very commonly known property, not only commonly known, we have looked at it specifically, derived it and wondered why this is so, but the final result is, if in a triangle two sides are equal, the opposite angles are also equal to each other. That means if this side is equal to this side, this angle is going to be equal to this angle. That means I apply the same logic here, this angle is going to be equal to this angle. And now we are going from theoretical proofs to problem solving, and the principles of problem solving are the same no matter what the topic, whether it's arithmetic, algebra or number system. Wherever you have a variable and you do not know the value, assume the value to be x and build your story accordingly. So basics of problem solving, I call it x now. So I know this is x, this is also x. Next what I will do is, I will notice this triangle ACD, and this becomes the exterior angle. I have a triangle ACD and this is the exterior angle created by extending this side, right? So this is the exterior angle for the triangle ADC, and I just looked at how the exterior angle is equal to the sum of the opposite angles. That means this angle is going to be x plus x 2x. Now quickly focus on triangle CDB. These two sides are equal. That means these two angles are going to be equal. Once again using the same property. So this will also be 2x. So a lot of jumping is done already. Now at this point there are multiple ways of going about it, but perhaps the faster way is, forget this line for a bit and notice the triangle ACB, and CE is created by extending AC. That means this angle is the exterior angle. This angle is the exterior angle for the triangle ACB. That means this angle is going to be the sum of the opposite angles. Sum of opposite angles is going to be x plus 2x. That means this 96 degrees is equal to x plus 2x. That means 3x is equal to 96, and x will work out as 32. And my question was, what is angle DBC? My angle DBC was 2x. x is 32, so 2x for me will become 64 and my problem is done. And this is one way of doing it, and if you have used some other method, maybe you started playing with the equations here in terms of, you can see this is also 180 degrees, that is also fine. Remember in geometry, for most problems there might be multiple ways of approaching it, especially if your tool collection is high. That means you're very thoroughly aware of every possible theorem. You might look at this problem from different angles as such, but as long as your answer finally comes out right and you're very clear about what is happening, my answer is going to be angle DBC is going to be 64 degrees. So this was our next problem marked as example 3. This is the figure given to me, and I know that angle EFC, this angle is 120 degrees. This is the information given to me, and my question is, what is the sum angle A plus angle B plus angle D going to be? So let me start playing with this. First of all, I notice a straight line. I know this angle is 120 degrees. That means this angle is going to be 60 degrees. Why is that? Because sum of all the angles on a straight line is always going to be 180 degrees. So this angle plus this angle is going to be 180 degrees. If this is 120, 180 minus 120 gives me 60 degrees. Now if this angle is 60 degrees, this angle is also going to be 60 degrees. Why is that? Vertically opposite angles, day 1 theory, right? Vertically opposite angles are equal to each other. In fact, even that these two angles are equal to each other can be derived from this idea that on a straight line everything is 180, but we have already done that, so we will not get into the details of this right now. So I know this angle is 120, this angle is 60, this angle is also 60. And now zoom into this triangle FCD, triangle FCD, and take the side DC and extend it going to A. That means this is the exterior angle. That means angle ACF is going to be angle D plus 60, because the exterior angle is the sum of the angles on the opposite side. So angle ACF is going to be angle D plus angle, so angle ACF is going to be angle D plus 60 plus 60. Angle DFC I already know is 60 degrees. So I know angle ACF, which is the exterior angle for this triangle, extend this side and you create an exterior angle, is equal to 60 plus angle D. Similarly, now focus at triangle EBF and think of the side BE extended. That means this is the exterior angle, and once again this exterior angle is going to be the sum of the opposite angles. So angle B plus 60. That means angle AEF is equal to angle B plus 60. And one last point to notice is that I have a quadrilateral here. AEFCA is a quadrilateral, and the sum of all the angles in a quadrilateral is going to be 360 degrees. That means angle A plus angle AEF plus angle EFC, which I already know as 120, plus 120 plus angle ACF is going to be 360 degrees, because in a quadrilateral sum of all angles is always going to be 360 degrees. So angle A, let it be here. Instead of angle AEF, what can I write? I can write angle B plus 60. So instead of this, I will write angle B plus 60. Instead of angle ACF, what can I write? Angle D plus 60. So I will write angle D plus 60. And now I have it, whatever expression I wanted, I have it in this equation. Angle A plus angle B plus angle D. So angle A plus angle B plus angle D. And I have a 60 and a 120, which is 180, and a 60 again, so a 240, which will be subtracted from the other side. So 360 minus 240, and I will get 120. So angle A plus angle B plus angle D is going to be 120 degrees. So the properties that we are using in this particular case was that sum of all angles on a straight line is 180 degrees, that the exterior angle is equal to the sum of the opposite angles, and that in a quadrilateral sum of all angles is going to be 360 degrees. So a simple problem and a revision of all our key ideas. So this was our next question. in triangle DEF, A, B, C are taken on DE, A is taken on DE, DF and EF respectively. So A is on DE, B is on DF and C is on EF. It is also given to me that EC is equal to AC. So EC is equal to AC. Moreover, CF is equal to BC. So CF equals to BC. And it is given to me that this angle is 40 degrees. So angle D is given to me as 40 degrees. And the question is, what is the measure of angle ACB? So this is the angle that I have to figure out. This is my question. So let's start working on this. And once again, I notice that these two sides are equal. That means if this angle is X, this angle is also going to be X. And similarly, if you want to name it, if this angle is Y, this angle is also going to be Y. That means these two angles are going to be equal to each other. And once again, very many ways of approaching this. I want to focus on this angle ACB, and I know I can figure out angle ACB. Angle ACB is equal to 180 degrees, because on this straight line, this angle plus this angle plus this angle, this angle plus this angle plus this angle are going to add up to 180 degrees. So from 180 degrees, if I remove this angle and this angle, I'll get the value of this angle. So that is what I'm trying to do. Angle ACB is equal to 180 degree minus angle ECA. Angle ECA itself is 180 minus 2x. Why is that? Because if I think of triangle AEC, angle X plus angle ECA, they are going to add up to 180 degrees. So 180 minus these two angles is going to give you angle ECA. So angle ACB is equal to 180 minus angle ECA, and instead of ECA I will write 180 minus 2x, which will become a plus 2x. If not clear, minus bracket 180 minus 2x, so this minus minus will become a plus. Am I done now? No. I also want to subtract this angle from this story, from this 180 degrees, and this angle, angle FCB, similarly angle FCB is going to be 180 minus 2y. So I subtract this also from this story. So far I had 180 minus 180 plus 2x. From this further subtract minus 180, and that minus 2y will become a plus 2y. So if I am looking at angle ACB, I can find it so. From 180 degrees, I am subtracting these two angles. What other piece of information do I have? I know that if I think of triangle DEF, and triangle DEF is going to be made up of angle D, angle X and angle Y. So I know 40 plus X plus Y is also going to give me 180 degrees. 40 plus X plus Y is going to give you 180 degrees. So X plus Y is going to give you 140 degrees. Go back to your equation. First of all, from this 180 is subtracted. And now reorganize this a little, and you will see 2x plus 2y minus 180. Angle ACB is 2x plus 2y minus 180. I know x plus y is 140. So 2x and 2y is going to be 280 degrees, double of that. That means this 2x plus 2y is going to be 280 degrees. 280 degrees minus 180 is going to give you 100 degrees. That means this angle ACB is going to be 100 degrees. So we've got the answer, and it is possible that you might have taken a completely different journey altogether. But again, as long as your final answer is right and you're sure about your process, that is absolutely fine. And again, there are a lot of ways of playing around with this. I know this angle is going to be the exterior angle for this triangle. So this angle is going to be this plus this. This itself is going to be 180 minus 2x. So I can figure out some value for this. Similarly, I can figure out some value for this. And then again, I can play around with a quadrilateral that all the angles are going to be 360 degrees and make this story, and whatever way works for you. But sticking to very basic ideas, and we have our answer. So let's look at the next problem now. There is a triangle ABC, and it says it is an isosceles triangle with AB is equal to AC. AB is equal to AC. So this side is equal to this side. Furthermore, point P is on BC. Point P is on BC somewhere, and point Q on AC. Point Q on AC, such that PA is equal to AQ. Such that PA is equal to AQ. This is the same line. I'm just drawing it separate just to so that I can draw another symbol. That means this AQ part is equal to AP. So this is the other part of information given to me. Furthermore, angle BAP was given as 30 degrees, and your question was, what is angle QPC? Angle QPC is what you have to figure out. Now let's get started. First of all, I know AB is equal to AC. So if this angle is X, this angle is also going to be X. And if this angle is Y, this angle is also going to be Y. Why is that? Because AP and AQ are equal to each other, so the opposite angles are going to be equal to each other. So I have this much information, and this angle is given as 30 degrees. The next step that I can take is think of triangle ABP and think of the angle APC. So this angle is the exterior angle for this particular triangle. So angle APC is equal to X plus 30. X plus 30. I wanted to think of angle QPC. Angle QPC, this angle, I know the big angle is X plus 30. If I remove Y from it, I will get angle QPC. So angle QPC is X plus 30 minus Y. Now think of triangle QPC and this CQ extended outside, and this becomes the exterior angle. So I know this angle is going to be the sum of angle QPC plus angle QCP. This angle I just figured out was X plus 30 minus Y, and this angle I already know is X. So Y is equal to X plus 30 minus Y. So this Y goes here, you get 2Y, you have a 2X and a 30. Take 2 common from everywhere, you get Y is equal to X plus 15. And I wanted to figure out the value of angle QPC. You are just saying Y is equal to X plus 15. So instead of this Y, write a X plus 15. Solve this. X plus 30 minus X minus 15. X gets cancelled. 30 minus 15, you get the value as 15 degrees. And again, you might have taken a completely different direction, but overall we are talking about the problem solving approach. That means I know some ideas, I will name them as X and Y, and then I will play around with other properties till finally I get to my answer. So my answer is angle QPC is going to be 15 degrees, and I use the properties of isosceles triangle, and I have used the property that the exterior angle is going to be equal to the sum of the angles on the opposite side. So our next question is, there is a triangle ABC, and D, E and F are points on AB, BC and AC respectively. So D, E and F. Further it says that ED is the angle bisector for angle AEB. That means this line is bisecting the angle AEB. That means this angle is equal to this angle. Furthermore, it says EF is also an angle bisector for angle AEC. That means this angle is equal to this angle. Name them if you want to. Angle BED is equal to angle DEA, and angle AEF is equal to angle FEC. If I call this X, this will also be X. If I call this Y, this will also be Y. So I see 2X plus 2Y is going to be 180 degrees. Why is that? Because sum of all the angles on a straight line is always going to be 180 degrees. That means X plus Y is equal to 90 degrees. In fact, I am not even done with the instructions of the equation right now. It says further angle BDE is equal to angle ADF. So connect this D and F also. And it says angle BDE, this angle is equal to this angle. Call it A for a minute. So if this is A, this will also be A. Similarly, it says angle EFC, this angle is equal to this angle. Call this B, this angle will also be B. And you have just figured out that x plus y is 90. This was x and this was y. That means angle DEF, if I think of triangle DEFE, the angle DEF is going to be 90 degrees because I just figured out that x plus y is equal to 90 degrees. So I can think of this as a 90 degree angle. That means this angle, angle FDE plus angle DFE plus angle DEF, all of them are going to add up to 180 degrees because this is a triangle and I am talking about the sum of the angles inside a triangle. So I know this angle plus this angle plus this angle is going to be 180 degrees. But what is this angle? This angle itself is 180 minus 2A, because think of the straight line ADB, angle A is gone, angle A is gone, this is what you are left with, and the sum of all the angles was 180 degrees. So from 180 subtract these two angles and you will have the value of this angle. So this angle is 180 minus 2A. Similarly, this angle is 180 minus 2B. Work with this now. I know this angle plus this angle plus this angle is going to give me 180 degrees. So 180 minus 2A plus 180 minus 2B plus 90 is going to give me 180 degrees. So this 180 gone straight away. And this minus 2A and minus 2B I'll move to the other side. This will become 2A plus 2B. And this 180 plus 90 gives me 270. 2A plus 2B is equal to 270. I will remove the 2 and I'll get A plus B is equal to 135. So A and B, I know A plus B is equal to 135. Now forget this line for a minute and focus on triangle ADF. I know A plus B plus this angle A is going to be A plus small b plus the big angle A is going to give me 180 degrees. Why? Sum of all the angles in a triangle is always 180 degrees. I know A plus B is 135. So this is 135 already. I can very quickly find out the value of angle A as 180 minus 135 and you are done. And you are done. So on the surface it might look very tricky, but stick to your basic processes and your job is done pretty quickly. So our next question is, there is a triangle ABC, and there is a point on D such that AD is equal to AC. So if you draw this line, AD is equal to AC. So capture that information for yourself, AD is equal to AC. So once again I'll use the properties of an isosceles triangle. So I know whatever this angle is going to be equal to that. That means if this is x, this is also going to be x. What else is given in the question? That angle ACB minus angle ABC is equal to 50 degrees. For a minute, for easy reference, I'm going to call this angle 1 and I'm going to call this angle 2. So I know angle 1 minus angle 2 is 50 degrees. Just so that we don't have to write ACB, ABC over and over again. So this would be angle 2 and this whole thing is angle 1. Now I start thinking multiple ways of doing that. You can think of this as an exterior angle for the triangle BDC. BD is extended, creating an exterior angle, and this angle x is equal to angle 2 plus angle DCB. Angle DCB, this small angle. This angle DCB is going to be angle 1 minus x, right? Because angle 1 was ACB, the whole thing. From this, if you remove x, you will be left with DCB. So angle DCB is angle 1 minus x. I am thinking of angle ADC, which is the exterior angle for this triangle. That means this x is equal to angle 2 plus this angle, and this angle is nothing but angle 1 minus x. Let me move this x here, so I get 2x is equal to angle 2 plus angle 1. If I just play with this equation a little bit, I can rewrite this as angle 1 is equal to 50 degrees plus angle 2. So instead of angle 1, I will write 50 degrees plus angle 2. So I get 2x is equal to twice of angle 2, whatever that is, plus 50 degrees. Divide everything by 2, you get x is equal to angle 2 plus 25 degrees. So most of our work is done. Our question was, what is the measure of angle DCB? Angle DCB I know is angle 1 minus x, and I just figured out angle x is equal to angle 2 plus 25. So angle 1 minus angle 2 plus 25. This will become angle 1 minus angle 2 minus 25. I already know angle 1 minus angle 2 is given to me as 50 degrees. So this would be 50 degrees minus 25 degrees. My answer would be 25 degrees. So finally my answer, angle DCB, is going to be 25 degrees. And once again, I have used the exterior angle. You could have also said that no, I will think of the triangle BDC and look at the sum of all the angles. In that case, I would have said this angle is 180 minus x, and the story would have continued in the same vein. 180 minus x plus angle 2 plus angle DCB is equal to 180, and you would have written that equation and would have simplified into the same thing. Essentially, you want a relationship between the x and one of these angles, and then connect the story and you will have your answer. So again, looks tricky, but notice finally we have solved it using our very basic properties. Rest of it is the problem solving approach, naming things, building equations, connecting them together, and obviously struggling with them and then finding the final answer is 90% of the fun in doing such things. So this was the next question, and my answer would be option 2, 25 degrees.